Please. Okay. These are also before integration. I made a small video series before integration for you. So there are some small videos to make. So after finalize them, I will share them also with you. And today we are in the final parts of differentiation, and I said you today I explain you the some important key points before integration. Okay. Okay then. However, do you know what is discriminant? Okay. Today lesson is very free. Today lesson is very free. This is the before our seminar. Okay. This is like a trial. Okay. This is before our seminar. This is like a trial. So you are free to speak with me, and you can tell me what are your problems, and is any problems when you doing this syllabus or something, anything. Anything, you are free to make a discussion with me. Wait. Yeah. Okay. Do you know what is discriminant? What is discriminant? Now listen. Anyone in chats? Yeah. Okay. Don't worry. Don't worry. Then it is that before integration. Okay. Before integration, we should study about the quadratic functions. Okay. Quadratic functions. What are quadratic functions? Quadratic functions. The general form of quadratic function is Pudha ax squared plus bx plus c. Okay, general form of quadratic function is this. Then we define a thing called discriminant for a quadratic function. Okay, we define a thing called discriminant. So don't panic. Don't panic. With the value of discriminant, we can decide so many things. That is important for integration. Okay, that is important for integration. Okay, I know you don't know about integration. So today, okay, today listen to me the things that I say into you. Okay, don't worry, and you are free to ask any questions here. I think I know. I think. Can you put? Do you know the discriminant is anyone? What's discriminant? We discriminant as we define b squared minus 4ac in quadratic functions. Okay, don't panic. I'm teaching you. This is the discriminant. How this b and a are, c are coming from? This b, this a, this c. Okay. Oh, please wait. User ID. Please wait, Buddha. Someone is asking about user ID and password. Please wait. Okay. This is the discriminant. What is the importance of discriminant? All are to be discussed. Don't worry. Okay. Then this is the discriminant. Then What do you know about completing squares? What do you know about completing squares method? If anyone, please raise hand. Completing squares method. Now I am going to teach you completing square method. If you know, if anyone know about this, please tell me. Okay, you don't know. No, don't know. I will teach you from the beginning. Huh? Yeah, and remind will and yeah. Okay. Understand this discriminant, this completing square method, all are very important for integration. And integration is little bit hard. Okay, integration is not easy. Integration is little bit hard. Uh, it's like that. Okay, think about this. I think you don't know about differentiation, but don't think. The differentiation is we can differentiate x squared. No, okay. The people who don't know, don't panic. I will teach you what differentiation is. There are some videos also in my YouTube channel. The lessons I did previously. Okay, so don't worry. Please focus. This is the answer. If you don't know how this answer is coming, don't worry. Okay, this is a free day. No, this is free day. This is a discussion day. Okay. Discussing about our future plans in our class. Okay, so when I differentiate x squared, it's coming 2x. Okay, when I differentiate x squared, it's coming 2x. Then when I integrate 2x, don't think about this dx. When I integrate 2x, the answer is x squared. So getting this answer is the integration. Okay, getting this answer is the integration. So I think differentiation is easy. Okay, differentiation is easy. Yeah, I think. Okay, other side, the next side. Okay, the differentiation is easy. Differentiation, the reverse process of differentiation is the integration. Okay, yeah, reverse, yeah, reverse. The reverse process of integration. So don't worry. You don't know about these things, huh? I should explain these things step by step. To come this journey, to come this reverse journey, okay, to come this reverse journey, is discriminants, completing square methods are very important. Okay, don't get these things. Now we are going to study the completing squares method. Okay, Puta, always we apply completing square methods for such quadratic functions. See, ax squared plus bx plus c. Okay, how we apply completing square methods? When we going to apply completing square method for quadratic function, the first thing is you should make the coefficient of x squared is 1. Okay, you should make the coefficient of x squared is 1. How we made that? We made that we get in simple a to out and open the bracket. Then what's happening? X squared plus what's happened to here? It is b over a. See, ax squared, when a multiplied with b over a and a cancel out, and again bx is save. Bx is keep in here. See, I want to make the coefficient is 1 here. That's why. And here it is c over a. See, ax squared, when I multiply this, okay, a into b over a into x, this is okay, a and a cancel out, bx, a multiplied with this, a into a cancel out, and c is okay. Yeah, please raise hand, people who get that. Okay, you got that. Okay. Yeah. Anyone who don't understand, you can tell. See? Okay then. I think all are okay. 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 A message form. Please wait. The others also to send thumbs when understood. Yeah. Yeah. Okay. That's right. Okay then. Now this is the thing. This bracket is now changing to this bracket. It is because I want to open some bracket in here. Just put x. Now I going to apply completing squares method. Just put x plus get the half of coefficient of x. Okay, half of, it means half of b over a puta. Okay, you should get half of coefficient of x. Then half of b over a means puta b over 2a. And just put the entire square here. Okay, I will do more examples from this. Okay, I will do more examples from this using numerical values. So please wait and see this. There is COA also, and please ask when I expand this. See, now I am going to expand this x plus b over 2a entire squared. What's coming? X squared. Don't think what is this? Is it integration? No. This one or 2 days I want to do some before integration calculations. Okay, trigonometry also revising and quadratic function all. So please wait until those are completing. X squared plus 2 into x into b over 2a and plus b squared over, see, b squared over 4a squared. Then slowly ask, then see, when I expand this, x squared is coming. Okay, bx over a is coming. See, bx over a is coming. And there is an additional term, p squared over 4 squared, which is not here. Which is not here. It is also coming with this. So we have to subtract that. And don't forget about this COA. And don't forget about this COA. Okay, don't forget about this COA. Then I going to get a common denominator, puta. See, 4 and AA. I get a common denominator here. Now see, there is a here, x plus b over 2a entire squared. I get a minus out. Then what's coming with? I get a minus out. When I get a minus out, there is b squared. This is positive, no? See, this is positive, no? To become positive, this should be minus. See, minus b squared and minus positive. I write this as 4ac. Puta, this is discriminant. Okay? And here, this is common denominator 4a square. We should close the bracket, close the main bracket. Okay? This is the completing square method. Okay? In this side, there is ax squared plus bx plus c. Okay? This is the completing square method. And you can see that there is a direct relationship with discriminant and completing square method. In completing square method, we can simplify these quadratic functions. Okay, I know you can't see any simplification form here, but when we do integration like things, you can get the experience how it is easier. The process is when we converting this into this form. Okay, puta. Okay, now I want to erase the board, no? Okay, today get some papers. Don't get a book. Okay, you should get the book in tomorrow. Tomorrow is our fresh start, and my class, the students who are in class, you also get some paper and get some cut paper or something, and write these things. Okay, I will tell you the from which place you should start. Please wait. You should start write the topic before integration. Okay, now we are going to, after this, after you write this, okay, after you write this, I going to do some examples from this, and after that I will explain how the integration is easier when we using this completing class method. Okay, okay, can you write these things? Right, first, before integration, right? If you have any question, you are free to ask me. Yeah? Don't think like strange with me. Okay, don't strange with me and ask any question from me. Okay. Okay, I think it is good. When you finish writing, hands up. Huh? Okay. Then after you write before integration, first write quadratic functions. This is the general form of quadratic function. Write that also. General form of quadratic function. General form of quadratic function is this. After that, you write what is the discriminant. Discriminant is so important for integration. Na? You don't know, no? So you can experience that when we doing the integration lesson. So write, this is discriminant. This should be remember. You should remember this. What is discriminant? B squared minus 4ac. Hurry up, hurry up, hurry up. I think these are, I think there is a lesson called Puta quadratic function separately. Okay. There is a lesson called quadratic function. Have you done it? Quadratic function lesson? Anyone know who did it? In our A-level syllabus, there is a quadratic function. The sum of fruits, the product of fruits. Oh, okay, okay, okay. Sorry, sorry, sorry. No one is speaking with me, no. Yeah, thank you. Okay. Uh, okay, okay, okay. Okay, then write discriminant also. And after that, write this completing square method. I think Puda, don't write these things. Huh? If you won't write, it's okay. But remember, you should at very first, okay, after applying completing square method, you should make the coefficient of x squared this one. Na? Here it is a, no? So we are pulling out a simple a. Then b over a, c over a. Very easy. Right. Okay. Don't panic, no? Don't panic. Ask me. I like you are speaking with me. It's not speaking. You are just you can just put a message about questions about you. Okay. In combined maths, if you learn these things for according to the correct step, it's very easy subject. Huh? Time is the problem. Okay, time is the problem. 2026 A-level combined maths paper. Today there was the applied paper, and the Monday pure paper is easy, but time is not sufficient. Okay, many students are telling time is not sufficient like things. Okay, integration. Oh, yeah. Then for the don't you have physics? Don't you have physics in Friday? Don't you have physics? I think there is physics, no? Okay, okay, okay. Don't worry. Don't worry. Okay. Okay. When you, I hope to do another shy. Yeah. Okay. Okay. I'm also second shy person. My first shy result is CSS. My first shy result is CSS, Puta. I also nothing do. Okay. In first shy, in my first term I did so many works. In our class, for combined mathematics, I had the highest mark in my class. I'm Kurunagal in St. Anne's College. Okay. Then CSS. However, after the second term of my school second term, I didn't write any exams or anything. I didn't do any work. Okay. It means 2018 August. I sit for the first time exam. Okay. Then after I decided to do a second try in 2018 January. Okay. Okay. Don't give up. Okay. After that, I sit the exam for 2019 August. Okay. 2019 August. 3 years. Okay. I'm in Peradeniya University, engineering faculty. 3 years. Okay. This is my second try. Okay. I also do my exam in second try. So I work hard to this in 1 year. That's the specialty in 1 year. Okay. I must have been. I'm all island man. Oh my god. I set the exam for the Tamil medium. Yeah. Others also can tell me, yeah. After being in Royal and sea level, mark down in front of lies like yeah. So get a fresh start. Okay. Get a fresh start after the exam. Okay. Okay. This is how my life is going. Uh, So how achieve that result within I? Huta, yeah, I will send you the plan. Okay, I will send all of you the plan is I will sending. In 1 year, I work hard, Puta. I work hard and I do past papers. I do past papers. I think like from 1995. Okay. The main thing that I did is checking some theory, understanding the theory, checking some theory, understanding the theory, and just now, okay, just at the same time I doing past papers and I see the targeted questions, and for physics I mainly refer Rosa sir, Professor Rosa's Viorana. There are reviews in Professor Rosa sir. There are reviews for physics. In combined maths, in combined maths I did past papers, and I self learned the some theories also. Okay. I think you don't. I think do not need to buy. There are PDF also, but I want to find the English medium reviews. Okay, I will tell you. I will tell you. Okay, and in my second chai, there are 3 revision classes for me in Kurunagal. Okay, then when I came home, okay, when I came home, I doing studies till 2 a.m. and I sleep for 2 a.m. and then I wake up in 5 a.m. 3 hours of sleeping. Okay, I sleep in 3 hours in main 5 days, and at the weekend I sleep some. Okay, at the weekend, and when again start the weekdays, same schedule. Okay, did so many work with the correct plan, Puta. Yeah, I manufacturing and industrial engineering in University of Peradeniya, manufacturing and industrial engineering I have studied. Uh, so this is how I worked. Don't panic, okay? Don't panic. Don't worry. You can get a fresh start from today. Okay, you can get a fresh start from today, and I will send you a plan. Okay, I will send you a weekly plan for you for this group, so you can do all things according to that plan. Okay, always there should be a plan, Buddha. Okay, for everything. Okay, for everything, almost always we should have a plan. Okay, I will make the plan for you. I will make the plan for you. So you should do works according to that, and um It should be hard work. Okay. Okay, then I erase the things about me. Okay. Because, right. So many interesting things in my life also. Okay. Okay, then. I think you write this, no? Hands up if you finish these things. I think discriminant is always finished, no? Okay. Now it is okay, yeah. Okay, okay, okay. Anyone is didn't write? Please tell me, yeah. Okay. Okay then. Okay, this is completing square method. Now examples for completing square method. Okay. Now examples for completing square method. See, fx equals 2x squared plus 6x plus 1. See, fx equals 2x squared plus 6x plus 1. First, you should find discriminant. Okay. First, you should find discriminant. After that, we can apply the completing square method. Okay. Please tell me. Do this fast. Do this fast and find delta x discriminant. Start from here. Start from here. Okay. Start from here to boost to speed also. Okay. Try it. Okay. Find delta x. Okay. Find what is delta x. Delta x is b squared minus 4ac. Now what is this? Ax squared plus bx plus c. Now we can see that a is 2, b is 6, c is 1. Okay. Now what happening? Now what happening? Now what is b now? Putha, b is now 6. 6 squared minus 4, a is 2, c is 1. So 6 to the power 2 is 36 minus 8. So 36 minus 8, 36 minus 8, it is 28 Putha. Delta x is positive. Okay, when delta, it is important to understand and considering about the sign of the discriminant also for something. Please wait. Now I'm going to completing squares method. To apply the completing squares method for this quadratic function. First pull out 2. X squared plus this is 3x plus here it is half. Is it okay? Do the question. Okay, now what's happening? 2 and change the nature of the bracket and just put x, and here it is 3 over 2. Just get the all, these things are same in all quadratic functions, huh? Okay, it is same in all quadratic functions. This right in x and getting the half of the coefficient of b, like things, and entire squared. See, it is very easy, no? We should subtract the square of this final term. So square of 3 is 9, square of 2 is 4. And don't forget to this half. Don't forget half. Then 2. This is x plus 3 over 2 entire squared. And this is 2. And this is 2. Now here it is minus 9. And here it is plus 2. It is common denominator, Puta. Okay. 2. X plus 3 over 2 squared. Here it is. It is minus 7 no. Minus 7 over 4. Okay. Do you know? I can write this as a difference of 2 square. How I write that? I can write this as a difference of 2 squares. How I write that? Difference of 2 squares? Okay, please wait. Now this is a difference of 2 square, Buddha. See? I can write this right. And I can factorize this. How I factorize this? See? 2 x plus 3 over 2 minus root 7 over 2 x plus 3 over 2 plus root 7 over 2. For your sake of clarity, I will do this also in red pen minus and this is plus. I think now you can get some idea about this computing square method. We can factorize these quadratic functions also. See, this is very important for integration in future. Okay, did you get that? How I write this as a square of difference of 2 squares and how I factorize this? Kuta, if you have any questions, you are free to ask from me. Yeah? Ask and clear. Okay. Okay. Finish this. After you finish this, we can go to the another example. After we do 3 examples, I will define you, I will teach in you the relationship between this final answer and the sign of the discriminant. Okay, to understand that we have to do 3 examples. Please write this. Please write it quickly. Yeah? Okay, write this. I will put our second example, 4x squared plus 12x plus 9. 4x squared plus 12x plus 9. First find the discriminant. First find the discriminant. Okay, is it finished? Is okay? Okay. When you finish, please hands up. If you can hands up, it's very easy for me. That's why. Okay. If you finish, you can try this. The people who finish, you can try the second example. There is almost a week, almost a year for us. So it is very easy if we work step by step and with the plan. Okay, the people who finish this, you can start this and find delta x. Its delta x is amazing number. The delta x of this is amazing. If you have any questions, you can ask from me. Yeah, answer is 0. Very good. Is it amazing? It is amazing for me. Okay. Oh, someone is joining, no? Two. Okay. Very good. Okay, then. In here, the delta x is b squared minus 4ac, no? Now the b is 12, 4, a is 4, and c is 9, Puta. The square of 12 is 144. You should multiply this, huh? It also 144. Okay, 144 minus 144 is 0. Now you can realize and you can experience what happened to this when the discriminant is 0. Okay, just try this. Know this part. In here, when discriminant is 0, know this like part. This is cancel out. Okay, experience that. They are very important to integration. I think you can't understand that when you are doing integration one day, then you can experience that how these things are important to do integrations. Okay. 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 Now here it is 4x squared plus 12x plus 9. Pull out 4 here. Pull out 4. Then here it is x squared. What is here? 3 no puta. 4 into 3, 12. Okay. Now what is here? Just easy. 9 no 4. 4 is cancelled out and 9 is again okay. Then no, the bracket is changed, no? X 3 over 2 entire squared. And we should, before write this, we should deduct 3 squared and 2 squared. It is 9 over 4 puta. 3 squared is 9, 2 squared is 4. And don't forget this 9 over 4. Oh, is it amazing? No, 9 over 4 is cut off. Then it becomes entire squared. See? It is entire squared. It's just 4. X plus 3 over 2. Can you see can it change according to this discriminant? Okay, in integration, we considering about the sign and magnitude of the discriminant. If the discriminant is 0, integrating method is a special one. If the discriminant is having a value with a positive value, the integration method is another one. I will teach you what are those integration methods. Okay, don't panic. Just study to do these things. Okay, then hands up when you finish that. After this, I go into the third example. Okay, hurry up. I will see any messages from anyone. No. Yoga Meshak, no? Meshak, All Island Mathematics Olympiad silver medalist. Oh, what is your school, Buddha? Meshak? Oh my God, I think you are very genius son, no? Olympiad. If you have attended to the Olympiad competitions also, medals also. Okay, do this with hard work. I think it's very easy for you. Okay. Okay. No, you don't go beyond. Just only Puta. Only here. Okay. Only here. So we are doing completing squares method. We are doing completing squares method. I will give some small time for you. And I will put the third example, x squared plus 4x plus 5. People who joined just now, focus. When I do the third example, you can get that, okay? Okay. X squared plus 4x plus 5. The third example. X squared plus 4x plus 5. This is the general form of quadratic functions, Puta. This is the general form of quadratic function. Now here A, this is B, this is A. First find the discriminant. This is discriminant. This B is this B. This A is this A. This C is this C. This is the discriminant. So find the discriminant. Our third example. This is our third example. Yeah, it is negative 4. It is negative 4. Now you can experience that. What happened into this? What happened into this? What will be the final answer? When the discriminant is negative. Okay, we can experience that. Please wait. Now here B is 4 minus this is 4. A is 1 here. A is 1. And C is 5. 4 minus 5 into 4 is 20. So 4 minus 20 is Buddha minus 16. It is minus 16. Okay. Now we are going to apply completing square method. If there is a people who join now, you can get the method by see the way how I do this example. Now our function is x squared plus 4x plus 5. Then I'm going to apply the completing squared method. Okay, now I'm going to apply completing squared method. Okay, here just put x plus 2 square. See, it is very easy, no? It is very easy, no? And we should minus 4 and plus 5. What happens now? X plus 2 is squared. 5 minus 4 is 1 now. Oh, see? Now it is addition. Now it is addition. When the discriminant is negative. When the discriminant is positive, this is a square of two difference. Sorry, difference of two squares. Difference of two squares. It's a difference. When discriminant is 0, it's nothing here. When discriminant is negative, it is a addition. Okay? When discriminant is Please wait. Please wait. I think there's a problem in camera. Please wait. Is it okay now? I think it is okay, no? Okay, okay, okay. Okay, it is okay. So this, Ola, okay? Any problem? I think no any problems, no? If you have any, please tell me. Okay, okay, no any problems. Then here it is x plus 2 squared plus 1. So write that, no? Hurry up, write that. Okay. Okay, there are three parts. This is delta x, no? It is negative means delta x is less than 0. In here, it is delta x is equal to 0. In here, it is, if it is plus, delta x is greater than 0. So this is the summary, okay? This summary is very important for integration, okay? Right. I think I can erase this. So this discriminant is relevant to Kuta. This discriminant is relevant to the quadratic function ax squared plus bx plus c. So if the discriminant of ax squared plus bx plus c is negative, then we can express this ax squared plus bx plus c is in, how can we express that? I'm applying computing squares here. See, x b over 2a, what come into here? What's your idea? What's your idea? Oh, almost there is a here. We should get the a out, no? We should get a out. And this is a plus something. Plus something. Something means it's just a number. It's just a number. And I think this is reasonable. Always we can express it as a square, okay? Always we can express it as a square. Always we can express it as a square. Okay? Don't think about this k, it's just a number. In our example, k is root 7 over 2. In our example, k is root 7 over 2. Just like that. Is it okay? I think it is okay. Then here, when the discriminant is 0, we can express ax squared plus bx plus c as how? First we should pull out a and x plus just b over 2a squared puta. Only this. This bracket is not needed. Only this. When delta x is positive, in that phase, we can express this as a difference of 2 square also. First a here. Don't rewind these formulas. Huh? You should simplify with the steps. Otherwise, marks will be 0. Huh? not me. The examiners will put your mark 0. You don't remind these things. I write these things to writing these things for intervention. Okay, for the help of your intervention. Okay, in integration also in some places they are asking to show the steps, so you have to definitely you have to practice the uh, these steps of completing a square. In here it is, oh inky, so no, it is x plus b over 2a squared, it is minus, just put puta k square. Okay, write this summary, write this summary. The different ways that we can express the same quadratic function according to the discriminant. Okay, hurry up, hurry up and write. uh, Please hands up me, please hands up the people who finished the trigonometry. Please hands up the people who finished the trigonometry with writing. Don't stop your writing and tell me. Yeah? There is one. Yeah, okay. Hasiru Semin. Okay, very good. Have I done it completely? It completed the lesson. Trigonometry lesson is completed. Okay, okay. Others? What about others? Hasiru is okay. The person who, the people who finished the trigonometry lesson, I ask him. Okay. Any messages from you? No, no. We are doing trick again. Okay, okay, okay. After this week, in this week, 2026 people also people ask helping for me from me. There is physics subject also, no. After this, after our meeting, after this session, there is another session which is starting in 11:30 for the students who, there is my group. So today and tomorrow, yeah, today and tomorrow after our session, there's another session for me. Today and tomorrow for physics, and after next Monday, my all work is okay now for 2026. Syllabuses are completed, just doing papers again and again. After next Monday, uh, we can fully schedule in which how we do the trigonometry again. Okay, I revise in trigonometry complete lesson again for my students also. No, not my students. You are also my students. My previous class students who are in previous class, we did trigonometry, so we should revise completing again trigonometry. We again revising trigonometry lesson, and today also I revising some trigonometry concepts that are important for the integration. Okay, I raise this thing. I think all okay. Okay, then factorize it. I will teach you some techniques of factorizing also. So it is important for integration. Only five, only five questions. Just wait. Okay, check this. X squared plus 7x minus 1. For the first example, I will do for you. Puta, see this, don't think about that. X squared minus 5x plus 6. We can easily factorize this. How? X squared minus this minus 5x is written as minus 3x minus 2x, and here it is plus. Now x, I pull out x minus 3, and I pull out minus 2, and it is x minus 3. And now we can get x minus 3 out, and here it is x minus 2, x minus 3 and x minus 2. Okay, but please wait and check the discriminant of this. Discriminant of this is b squared minus 4ac. Now b is minus 5. Now it is b is minus 5. B is minus 5 now. Minus 4, a is 1, c is plus 6. See, minus 5, it is 25, 24, so it is 1. Okay, 25 minus 24, it is 1. Okay, then check the discriminant of this. The discriminant of this is b squared minus 4, a is 1, and c is minus 1 now. Now what happens? 7 to the power 2 is 49, and this is plus 4. What's the answer? It is 53. Discriminant is 53. Positive, positive. The discriminant is 1 here. Okay, okay, please wait. Now check this. Don't write anything. 2x squared plus 7x plus 5. There is a function called 2x squared plus 7x plus 5. Now find the discriminant of this. What's the discriminant of this? B is 7, 4, a is 2, and here it is 5, c is 5. 7 squared is 49. It is 4 into 2, 8, 8 into 5, 40. The discriminant is 9. See, the discriminant is 9. What is the difference between 1 and 9 and 53? 53 is in a group, in one group. 1 and 9 is in another group. Why is 1 and 9 is in another group? They are complete squares. See, 1 square, 1. 3 square, 9. Like that. Okay? Okay, okay. Don't write anything. Don't write anything. Now check this. 3x squared minus 8x plus 4. 3x squared minus, don't write these things in your note. Okay, don't write these things in your note. Just get a rough paper. Just get a rough paper and check. What is delta x here? B is minus 8. B squared minus 4. A is 3. And this is 4. 8 squared means 64. And this is minus 4 into 4 is 16. 16 into 3 is 48. 14, 6. See that? Okay, please wait. When the discriminant is a number which is 1, 4, 9, 16, 25 like number, 1 square, 2 square, 3 square, 4 square, 5 square, 36, 6 square, blah, 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 blah. we can factorize in this way. We can factorize that quadratic function in this way. These are very important to know before you get into the integration. There's a partial fraction part also there. It's not these things. Did you get that? In this way, you can factorize in this way all these things. Now, don't go to get these discriminants. Start as your first example is this. This is not the first example. This is the final one. Okay, I changed that. This is your first example. Write that, and here it is your second example. Here it is your third example. In second and third, don't get these discriminants. You don't know. You know now how to get discriminants. So what do you do? What should you do? Factorize. Okay. Okay, factorize these things. Hurry up. You can see these things also can be factorized in this way. Okay, hurry up. Okay. Okay, how we factorize this? First, you should target, you should multiply 2 and 5. Okay, 2 and 5, 2 and 5 is 10 no? Then it is very easy. 2x squared plus this 7x can be written as 2x plus 5x. It is 2x plus 5x plus 5. That is the way we get some numbers. We should find some numbers. From that numbers, the product of that number should be equal to the multiplication of this and this, the product. And the addition of those numbers should be equal to this number, 7. Then we can pull out 2x here. Then it is x plus it is 1. And from this, we can pull out 5 here. Then x plus 1. It is very easy. See, 2x plus 5 and x plus 1. Okay, factorizing session. In here also, I will give some time for you to factorize. After that, you can try this final. Its discriminant is 53. It is not in this set. So it can be some hard, a little bit hard, that factorizing, but I teach you how we do such type of factorizations very easily. Okay. Okay, it is okay now. This. Did you factorize? Hands up. Who factorized this? Hello. Only Sophie. Hands up. Who factorized this? Hello, are you there? We should multiply 3 and 4, no? So 3 by 4 is 12. How we should make 8 minus 8. 12. 4 by 3, it's not happening. Minus 12. 12, 6 into 2. It is okay, no? This can be done by the experience. So 3x squared, we can write minus 8x as minus 2, no, minus 6x minus 2x. It is easier to 2 and 4, 6 and 3 keep in closer. So pull out 3x here, and this is x. This is 2, and pull out 2, and it is x minus 2. And pull out x minus 2. Very easy. 3x minus 2. The same way. Same way. Same way. How we find that? From the discriminant. B squared minus 4ac. Okay. What about your condition? Please tell me. What about your condition now? Can I erase these things? Hands up. These two okay? Hands up. Okay. Okay. Okay, no? There are people. Okay. Good luck. If you have any quick problems about this, put a private message. Then also is it okay? It is okay. I will reply in you. Okay. Okay. Well done. Okay. Now the quadratic function of discriminant 53. It's an ugly number, no? 53. It's not beautiful. So how we differentiate this? X squared plus 7x minus 1. Can you differentiate it? It's minus 1. See? Only one way, no? See? This is 1, no? 1 plus 1, 1 multiplied by 1, it's minus 1. How we can't do this? Okay? There are no numbers satisfying this. Anyone who complete this? Miti Shan. No, I don't know your name. I think Miti. Have you done this? Have you completed this? Okay. Is it okay? Anyone who complete this? You complete this, no? Another one? No. How we factorize this? Puta, what is the sign of delta x? Sign of delta x is now greater than 0. It is positive. When the sign is positive, we can write those things as a difference of two squares. Difference of two squares, yeah, we can't factorize, but there is a method. Now we can use the competing square method for this. But if the sign of delta x is negative, you can't factorize for that. If delta x is 0, can factorize. If delta x is greater than 0, can factorize. If delta x is negative, you can't factorize. Now I am going to teach you how we factorize. When the delta x is greater than 0, it is positive. but it is not a squared number. It's the method is somewhat changed, somewhat different, but the method is completing squares method. Okay, see, x plus, sorry, x plus 7 over 2 entire squared. I think you remember this, huh? Completing squares. X plus 7 over 2 entire squared, and we should minus 7 square, 2 square, and minus 1 is there. Now, x plus 7 over 2 entire square, here it is 49, this is 4, this is minus 1. I get a common denominator here. Now what happened? X plus 7 over 2 entire square, and here it is minus 49 minus 4, minus 49 minus 4, and this is 4, and x plus 7 over 2 entire square minus 49 minus 4, it is minus 49 minus 4 means minus 53 over 4. Okay, we can write this as in this form. What is the square root of 4? It is 2, no? It is very easy, huh? I just put that. Now, x plus 7 over 2 is squared minus root 53 over 2 entire square. Now we can factorize easily this. How? X plus 7 over 2 minus root 53 over 2. X plus 7 over 2 plus, very easy, no? Root 53 over 2. If we factorize in this way also, it is when we express this in this form, in some places, integration is become very easy in future. So now practice this method. Hola, okay? Please tell me any. Hello, have you any questions? You can tell me. Otherwise, write these things. This is our final factorizing problem. There is videos, no? I will put the videos on YouTube by factorizing more examples. Okay, after that I go to the trigonometric revision for integration. Okay, before integration, the trigonometric revision for before integration. So finish these things. Okay. Hmm. Can I erase this? Hello, can I erase this? Are you there? Now the best part is starting a trigonometric things. And after that, we can go into the partial fractions before integration. Okay. Called divisible algorithm. Remember a thing called divisible algorithm? No. Okay then. Hands up. Who this finished this? Hello. Finish. Yeah, finish. Okay. There are some are still writing. No. Okay. 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 Right. Right and hurry up. Huh? There are CD formulas. Can you remember? Uh, please tell me the people who complete the trigonometry lesson. No, you don't do the trigonometry lesson here. Anyone? Okay. 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 Uh, yeah, only one. No. Okay. Okay. When doing integration. Okay. When doing integration. Then today after this, I will do a trigonometric revision for you. Okay. Trigonometric revision. Then you ask what I say, you should accept in formulas. Otherwise, we can't do this. I will do trigonometry again. Until that, okay, till you should accept me. Yeah, what I say, you should accept in trigonometry. These are also very important to the integration. Okay, can I erase this? I can erase this. No. Mm. Okay. What I write the topic important important trigonometric formulas for integration. Important trigonometric formulas for integration. Write this topic, Uta. Write this topic. Important trigonometric formulas for integration. Have you done this? All are done this? Have you completed this? Hello? This, our previous one? Is it okay? Okay, no? Okay. First one is Pythagoras identity. First formula. I think we all know that. What is the Pythagoras identity? The first formula is Pythagoras identity. Pythagoras identity is this. Sine squared x plus cos squared x. What is the answer of this? Sine squared x plus cos squared x. What is the answer of this? Sine squared x plus. Yeah, very good. It's 1. Please hands up. Who know this? Please hands up. Who know this? Please hands up. You don't know this. The people who no. All are hands down. Hands down. Now, please hands up. You don't know this. You never asked this. Hands up. Okay, now hands up. The people who know this. Sine squared x plus cos squared x equals 1. Okay, you know. All are no. Okay. Okay. If this is. Now what is the answer? Sine squared 2x plus cos squared 2x. What is the answer? Sine squared 2x plus cos squared 2x. What is the answer now? Okay. Any answers? What is the answer of this? Your answer is correct, Ashini, I think. Your answer is correct. What is the answer of this? Anyone? Hello? And please tell me, what is the answer of this? Sine squared 5x plus cos squared 5x. What is the answer of this? Please tell me. Okay. You're correct. All is 1. Huh? The only condition is this and this should be equal. If this and this is equal, always answer is 1. Write these things. Hurry up. Right. There are some more to go. Hurry up. Okay. Okay. Now, however, sine squared x plus cos squared x equals 1. Now, I divide all these terms by sine squared x. Now, what's happening? This is cos squared x. Sorry, oh my God. This is also sine squared x. And this is sine squared x. Now, what happened? This is 1. And what's this? Cos over sine? Cos x over sine x, Puta? What is cos x over sine x? is equals to, oh, it's cotta, it's not tan. Cot x. I think I told you, if you don't know these things, just accept. Huh? When I tell, just accept. Then what is sin x over cos x? I will revise trigonometry soon. From next week, I will start with integration. We doing integration and revising trigonometry, and I will give you the recordings also. Okay. All those things are free. Yeah? Trigonometry revision is almost free. Trigonometry revision. I just put them into the YouTube. Sin x over cos x equals tan x. Then cos x over sin x is cot is x, no? So the square of this cot squared x. Now there is another formula. 1 plus cot squared x. What is 1 over sin x? Hello? Do you know? Hello? What is 1 over sin x? It is cosec x. Yeah. It is cosec x. Now 1 over sin x is squared. So it is cosec squared x. So this is our second formula. Write this also. If you want, write these things also. Hurry up. Okay. Now it's okay. Now I divide this by cos squared x. Okay. Now I divide this by cos squared x to get the other formula, the next formula. Cos squared x. This is cos squared x and 1 over cos squared x. Now this is sin over cos tan squared x. This is 1. 1 over cos x. 1 over cos x is the sec x. So this is sec squared x. Okay. This is sec squared x. Write this formula also. Okay, write this formula also. Hurry up. Okay. Okay, Pythagoras identities all over. Now summation formulas. It is sin A plus B. Do you know how we expand sin A plus B? And sin not A minus B. It is cos A plus B. Anyone? Okay. Sin A, we can't write this as sin A plus sin B. Yeah? We can't write this as sin A plus sin B. This is sin A cos B plus, if here it is cos B, in second term is cos A. Cos A sin B. If this is minus, this also become minus. That is the way how it is going. When cos A plus B is cos A cos B, if this is positive, this will be negative. And it is sin A and sin B. If this is cos A minus B, it is cos A cos B. If this is negative, this will be positive. That is how we go in. Okay, write these three also. Hurry up. Hurry up and write these three also. Say minus B. And there is formula for tan A plus B also. I will revise this trigonometry soon. So, okay, I revise this trigonometry soon. You just remind these things. In here, its formula format is somewhat different. Tan A plus tan B, tan A plus tan B, and this is 1 minus tan B. You write these things, no? Okay. When we doing more examples in integration by using this, they become to usual as okay. Okay. Have you done these things? Can I erase the board? Please hands up when you finish. Please hands up. Right. Okay. Okay then. Now this is okay. Okay. When this becomes minus, this becomes minus and this become positive. Write this also. Okay, hurry up. Hurry up and write this also. Cos A plus B, sin A plus B, they are okay now. Okay. Now, there are double angle formulas also there. Double angle formulas. What are those double angle formulas? Sine 2a. What is the expand of this sine 2a? How we get the sine 2a? Any idea? How we get sine 2a? Sine 2a is equals to 2 sine a cos a. 2 sine a cos a. Cos 2a. There are three formulas for cos 2a. Okay, there are three formulas for cos 2a. So the derivations of these things, I will do when I revise in trigonometry. Okay, when I revise in trigonometry, I put the all videos of trigonometry revision is into the YouTube, so you can see those things. In that revision, I will show that, I will prove that how these are coming. So until that, just write these things up and please remember these things before integration. Okay. Okay, then we can easily write this as cos squared a minus sine squared a. Cos squared a minus sine squared a. See, this is 2a, this is a, this is a, this is 2a, this is a, this is a. Think, if they are, if sine a is there, we can write this as 2 sine a over 2 cos A over 2. That is the pattern. Okay, that is the pattern. Sin 2a, 2 sin A cos A. If it is sin A, then 2 sin A over 2 cos A over 2. Okay. Okay, I think okay, the person Ashini, I think Sophie or someone, please send the notes to the book. I think you have missed someone. So if you, Ashini, if you have missed some notes, I will send you the notes. Okay, then you can write and keep the space for those things and continue from here. It is a new topic. It is double angle formula. So you can continue from here. Sin 2a, 2 sin a cos a, and if there is sin a, it is 2 sin a over 2 cos a over 2. Now it is cos 2a. We can easily write this as cos squared a minus sin squared a. If there is cos a, we can easily write it as cos squared a over 2 minus sin squared a over 2. Okay. Now for cos 2a, I told you there are two formulas. There are three formulas. One formula is expressing cos 2a in terms of cos a and sin a. Okay. And there is another formula, we can express cos 2a only in sine terms. How we express only in sine terms? See. Only in sine terms. How we express that only in sine terms? Can you remember the Pythagorean identity? Sin squared a plus cos squared a is 1. Now what is the value of cos squared a? I can subject cos squared a by getting this sin squared a into this side. It is 1 minus sin squared a. See? cos squared a can be replaced by 1 minus sin squared a. So you can replace that. And here there is another sin squared a here. Then what's the final answer? 1 minus 2 sin squared a. But this is a, this is 2a. If there is cos a, how we should write? 1 minus 2 sin squared a over 2. 1 minus 2 sin squared a over 2. For cos 2a, there is another formula also, only in the terms of cos. Only in the terms of cos squared a minus, we can replace this sin squared a. How? How we can replace sin squared a? Sin squared a is easy, huh? 1 minus cos squared a. So I can replace, I replace for here, cos squared a minus sin squared a is 1 minus cos squared a. So it is, this is cos squared a minus 1 positive cos squared a. This cos squared a and this cos squared a is 2 cos squared a. And here it is minus 1. So this is the third formula for cos 2a. If there is cos a, if there is cos a, it is 2 cos squared a over 2 minus 1. So write these three formulas and highlight these things. Now I think all are okay. Hurry up. Hurry up and write these things. If you have any problems, please tell me. Otherwise, hurry up. Write these things. And I will prove all these things in our trigonometry revision, totally free. I will put those things, those videos into the YouTube. Then you can see. But watch those things as soon now. Only 1 year is left for us. There are so many lessons here. Applied also, applied is almost there. So after I putting the videos, you watch those videos as soon as you can now. Okay. Mm, these things. Mm. Hands up who finished this, who finished the writing. Hands up who finished the writing. Okay, one is finished now. Two is finished. Okay, two. Sophie. Okay, you finished. Okay, this finished. What about Mitti? I don't know. Mitti-san, no? Have I finished? Okay, she is okay. Okay. Mitishan, I don't know your name. Also, okay. Don't hand up here. That's right. Okay, I think all are finished. Huh? Okay. These are double angle formulas. Now, tan 2a. There is tan 2a also. What is tan 2a? Equation of tan 2a? 2 tan a, 2 tan a, 1 minus tan squared a. 2 tan a, 1 minus tan squared a. Write that also. 2 tan a, 1 minus tan squared a. Okay. After that, there are triple angle formulas. After that, there are triple angle formulas. It is sine 3a. Okay, triple angle formulas. I will erase this. Huh? Sine 3a. Okay, for this, I will show the way of proving this, because for this, definitely you should learn the method of proving, uh, instead of writing just a equation. Okay, because of that, I will do this. In here, I apply the equation of this sine a plus b. What is sine a plus b? Sine a cos b cos a sin b. Sin a cos b cos a sin b. Then I write this as sin 2a plus a. See, sin 2a plus a. This 3a I write as 2a plus a. Then what happens? Sine 2a cos a plus cos 2a. This is cos a, no? So this is cos 2a sine a. And I will apply for this 2 sine a cos a, and there is another cos a here. So it becomes cos squared a plus cos 2a. How we write cos 2a? Uta, this is sine, no? This is sine. So definitely we should express this sine 3a in terms of sine. In terms of sine. So I will apply the formula only in the terms of sine. Na? So cos 2a can be write as 1 minus 2 sine squared a. We proved above. And this is sine a. Why I choose 1 minus 2 sine squared a for cos 2a? There were three options. I want to express the sine 3a only in the terms of sine. So I replace this also by 1 minus sine squared a. So this is 2 sine a, and this is cos squared a is 1 minus sine squared a. I will multiply, yeah? Sine a minus 2 sine c cube b. Now what's happened? It is 2 sine a minus 2 sine cube a plus this is sine a minus 2 sine cube a. I'm not teaching you trigonometry. Yeah? These are only before integration. Okay. Tomorrow we start the integration lesson. Okay. I think today also we'll try. Yeah. Okay. Now 2 sine a plus sine a is 3 sine a. Minus 2 and minus, oh my god. Oh yeah. Minus 2 and minus, so it is 4 sine cube a. Okay. Now it replaced sine 3a. So please, this 3a is divided by 3. Divided by 3. If there is sine 6a, what's happening? It will sine 2a minus 4 sine cube 2a. Always when we apply in this triple angle formulas, this will divided by 3. When we apply this, 3a divided by 3, then a. 6a divided by 3, then 2a. If there is 9, this becomes 3. Okay, right. Sine 3a. Only there is cos 3 and tan 3a. After that, there is small substitution technique. There is a small substitution technique in trigonometry that important for integration. After that, the old trigonometry formulas also over for integration. Okay, I will today I will integrate at least one function with you. That is my target. So write this. At least I will integrate with you. Integrate only at least one function. Please write these things. Okay. Can I erase the board? Can I erase the board? Hands up. Who finished writing? Hands up who finished writing. Okay. People who finished, try with cos 3a. Try with cos 3a. Okay, I will give some time. I think mic is on. Some mic is on. I think my turn off the mic. Okay, I think it's okay now. Now we should try to cos 3a. Now we should try to cos 3a. Okay. Cos 3a should be expressed in only in the terms of cos. Then as a first step, I write 3a as 2a plus a. Then cos 2a, we can apply the formula for cos a plus b. This is 2a plus a, no? What's the formula? Cos a, cos b. If this is positive, it should be minus sine a, sine b. Now, this is cos 2a, cos a. This is minus sine 2a, sine a. Then cos 2a is, we should express in only in terms of cos. So I prefer the double angle formula 2 cos squared a minus 1. We proved above this. Not proved, just written. And this is cos a minus sine 2a is very easy. 2 sine a cos a. And this is sine a. Now what happens? This is 2 cos cube a. 2 cos cube a minus cos a. This is minus 2. See, this sign and this sign becomes sine squared a. And this is just cos a. Now what happens? We should express all these things. We should express all these things in the terms of cos, no? So this is 1 minus cos squared a. So this is cos a. Now this is cos cube a minus cos a, and this becomes minus 2. See, cos a and minus 2 cos a. This is cos cube A. See, cos A multiplied by cos squared A. So with this minus, it is minus cos cube A. Minus cos cube A is multiplied with this minus 2. Then this become plus 2 cos cube A. So 2 cos cube A, 2 cos cube A. So they are like terms. 4 cos cube A minus cos A minus 2 cos A. So it is minus 3 cos A. Cos 3A. Hurry up. Please write. Quickly. Quickly write. Quickly. Very easy, no? Okay. Can I erase the board? Can I erase the board? Hands up, hands up, hands up. If you write up, if you finish this. If you finish this, hands up. Okay, no? Okay, I will erase. Then tan 3A. Tan 3A. It's also same. Tan 2A plus A. You try this, huh? You try this at home because you know the formula for tan A plus B. Okay? You know the formula for tan A plus B, no? What is that? Tan A plus tan B 1 minus tan A tan B. So try this with this formula at home. I will write the the identity. Yeah? 3 tan A minus tan cube method. Tan 3A is 1 minus 3 tan squared A. So you just write this. Okay, you just write this. See, this is 3a, this is a, this is a. You just write that, write this, and uh, uh, try to get this with this formula at home as a homework. Okay, then triple angle formula also okay now. There's only one subtopic is left for us. That is expressing. This is very important for trigonometry. This is especially important. Expressing tan in term. No. Sorry. Expressing sine and cos. Expressing sine and cos in terms of tan. Expressing sine and cos in terms of tan. This is our final subtopic of the trigonometry sessions of integration. And today I will integrate at least one function. Nah? So it is time. Oh, no, its time is 9:57 now. Its time is 10. Still it is 10. So we have the time. So I think I can erase this. Okay. This means you should express sin x. Okay, you should express sin x and cos x in terms of tan. Can you do that? Hands up. If you know to do this sin x and expressing sin x and cos x in terms of tan x. Hands up. Anyone who know? I want to know that. That's the thing. It's no other thing. You don't know. You don't know to express sin x and cos x in terms of tan x. No one? No. Hmm. Okay. Okay. See, we can write sin x as this. Agree with me? Do you agree with me? Sin x over 2, cos x over 2. We can write sin x in this way. Sin x over 2 and cos x over 2. Do you agree with me? Please hands up. If you agree, please hands up. This is the formula of sin 2a. Sin 2a is 2 sin a cos a no puta. Then sin x is 2 sin x over 2 cos x over 2. Okay, please hands up. Are you sleeping? Huh? Hello? Hmm. Don't know, some people not speaking. What about others? Okay. Sin x over 2 cos x over 2. Then see, what we need, what is our purpose? What we need, the need is expressing these things in the terms of tan. So to get tan, I will divide this by cos x over 2. I don't know about the future pathway of this, but to get tan, I will divide sin x over 2 by cos x over 2. But we can't divide according to our plans. If we divide something in a mathematical expression, we should multiply same thing in the above layer also. Then it is cut off and the expression is balanced. Now what happens? 2 sin x over 2 over cos x over 2 means it is tan x over 2. And here it is cos x over 2 multiplied by cos x over 2. It is cos squared x over 2. Then what happens? We know 1 over cos x is sec x. Then 1 over sec x is, when I put sec x here, cos x we can put in here. See, we can exchange these sec x and cos x. When 1 over cos x is sec x, and if we place sec x here, cos x here, then 1 over sec x is cos x. Then see, cos squared x is equal to 1 squared x 1 no, 1 squared 1 no, 1 over sec squared x. Then what happens? 2 tan x over 2 multiplied by, I replace this cos squared x over 2. This is x, this is x over 2. Cos squared x over 2 by 1 over sec squared x over 2. In this way, it's not tan, no, it's not tan. But in Pythagorean identity, I teach you 3 formulas of Pythagorean identity. The one is this: 1 plus tan squared x is sec squared x. Then I can replace these things. Tan x over 2 is same. Sec squared x over 2 can be replaced by 1 plus tan squared x over 2. So this is the expression of sin x in the terms of tan. What about your idea about this? Please tell me. Do you know this thing, this technique in previous, or you studied this in just now? I want to know that. I want to know that. I want to know is you learn from this from in this class or in previous. What about your idea? If you can, please tell me. However, write, quickly write. There is to express cos also in terms of tan. Okay. Okay, now cos. Can I erase the board? It is okay for you, no? Okay. Okay, now cos. Cos x. How we express cos x in terms of tan? First, we have to apply double angle formulas. It's not double angle formulas here. It is. I think it is better to say it is half angle formulas. Cos squared x over 2 minus sin squared x over 2. See, this is very interesting. Huh? This proof is very interesting. Why is it? What is the number in denominator? It is 1. So we can replace this 1 by cos squared x over 2 plus sin squared x over 2. We can replace this one. And we can divide all these terms from what? We can divide all these terms with cos. Huh? Then it becomes in the terms of tan. That's why when we divide these terms in cos, this becomes 1, this becomes 1, this becomes tan, this becomes tan. It's very interesting, no? For me, it is very interesting. See, those are the things that asking for the exam also. See, dividing all terms, all 4 terms by cos squared x over 2. Now what's happening? This is 1, this is tan squared. Be careful, x over 2. And this is, sorry. This is minus. This is minus. Okay. I express the cos x also in terms of tan. We can't express it. It is in terms of tan x, in tan x over 2 cos x. Okay. Now, before integration, trigonometry part is over. But there is a thing. What's do you know? The partial fraction and polynomials. Okay, it also a part that we should complete before integration. But now we can do some integrations. Now we can do some integrations without those things. Huh? So write these things. So today we start our first integration. So write this. We start the first basic method of integration, that is simple power law. Write this. After this we can go to the simple power law. Okay. Now, how we integrate things. Okay. What is integration? A simple definition I will explain now. Okay, a simple definition for this. Okay, is there a signal drop? No, no. Okay, I think no any issue in video, audio. Okay, if you have any, please tell me, then I can check with this. Okay. Okay. First, the thing is this. Okay. First, there is a constant multiple rule. The first rule in integration method. Basic rules of integration, basic rules of integration, and the first three rules of integration is not related to integration. They are just the rules that we can do here. You can get that. Think, if you want to integrate, this is the symbol of integration. Okay, that is a symbol of integration. The things to say you, this is the symbol of integration, and something also to tell you. See, we can differentiate this one. See, we can differentiate fx, we can differentiate not fx, y, we can differentiate y with respect to the x is here. This is differentiation. Okay, then think the answer of this is y dash. Just tell it is y dash. When we differentiate the function y, the answer is y dash. You just think. Then we can do that now. We can subject dy like this, y dash dx. See, we can subject dy y dash dx. And the standard symbol of integration is this. You can think it is not equal. You can think this integration symbol as 1 over d. It is not equal. Please don't substitute 1 over d into all places of this. But you can use that for some derivations like this. See, it is dy now. So we want to subject y puta. That is integration. For that, we put this symbol to both sides. Now, see, don't substitute. Keep it in your mind. This is one node, you know. When you imagine, imaginary, you can substitute one node d. Okay, d cancel and it is y. Don't substitute it. There is a reason I will teach you. Please wait. Now, what happening? When I integrate all integrations, there should be this dx. This dx, so something with d should be there before the integration. Always there is a something. For this also there should be that thing. When we differentiate this, we can get this y. So that is the basic definition of integration. So think this k is, there is dx here always. Think k is constant here. If k is constant, you can get k. Okay, you can get k out from this integration symbol. That is the first rule, simple constant rule. But in here, we don't study how we differentiate fx. Only the taking constants out. As an example, think you want to differentiate this 2x squared plus 4x plus 6. in here you can get a 2 out of this integration symbol. You can get that x squared plus 2x plus 3. But integrating this will be another technique, integration of this. It's not studied in here, but only the thing we studied in here is taking this common term, so constant out of this. Write these things. If you have any doubt, you free to ask me. Otherwise, write these things. All these things write in your paper, not in your book. You can use your book in tomorrow. Tomorrow is the fresh start of integration. Tomorrow is the fresh start of integration. You can use a new book for that. Today, just write these things in a paper. Okay. You can write another example also. If you want to differentiate 2 sin x, you can get this 2 outside from the integration side. Now you should only integrate sin x only. 2 is multiplied to the answer. How we differentiate sin x? That's the thing, huh? Okay, we can study. Write all these things. And I will write the second one also. If there is like this, see, you want to integrate fx plus gx dx, you can easily write this as, you can integrate those things separately. You can get 2 dx's to these things and you can integrate these things separately. Example, if you want to integrate 2x squared plus 2x plus 3 dx, then you can separately integrate x squared dx plus integrate 2x dx, integrate 3 dx. So here x squared dx is here, it is same. How we differentiate this? We will study, please wait. You can get 2 out from the integration here, x dx. You can get 3, there is nothing here, but we should integrate. There is a way. But I want to teach you this method. You can separate these things in separately. You can integrate separately the entire function, which is oh, please wait. We can only use this. We can only use this for additions and subtractions only. Yeah? If there is multiplications and divisions, there are many smart ways to integrate. You can't apply these things. Huh? I mean, this, if you want to integrate this fx over gx, it's very good. I write this as completely wrong. Fx dx. Oh my god. Don't write these things. Completely wrong. Divisions and multiplications, these are not possible. These are not valid. Okay. Only subtractions and additions. These are very small things. Hurry up. Now we can study the simple power rule. Simple power rule. Okay. Now write simple power law. Now we starting integrating. Simple power law. Now we are learning to integrate a small function like x squared. Okay. Like x squared. Now we are going to study that, to learn that. Okay, write the subtopic simple power rule. Okay, write simple power rule. The rule is this. When n is not equals to -1, when n is not equals to -1, you can integrate xn dx with using this formula. How we integrate x n plus 1 over n plus 1. X n plus 1 over n plus 1. And please wait. This is the rule. And always when we integrate in something, always we should write a constant. I will explain you why is that. Now you know when I integrate xn, it becomes this. No, this is the rule. The integration is the reverse process of differentiation. No, integration is the reverse process of differentiation. It means, see, if I differentiate this, see, x squared plus 2x plus 1, how we can differentiate? We can differentiate this. X squared can be differentiated 2x. 2x can be differentiated as 2. And I think you know the differentiation of constant is 0. It means we can differentiate these things separately, no? D squared over dx plus 2 dx over dx. See, I get this 2 out and dx over dx plus d1 over dx. So how we differentiate this? This is 2x and this is 1, dx over dx 1, the way of differentiating. Keep remind, the differentiation of all constant is 0. The differentiation of all constant is 0. This is differentiation. Then the reverse process is integration. See, so if we integrate 0 also, there should be a constant, or this may be or not. This may be. So this constant can be 0 also. So when we integrate any function, it can be there is a constant, because see, when we integrate 0 also, there is a number 1 or 2 like answer. So when we integrate anything, we should put a constant here. Don't worry, you push for every integration you doing from here, every integration, after that integration, just put a c. Okay, just put a c. And we are writing c is an arbitrary constant. We are writing here c is an arbitrary means abhimata, arbitrary constant. Abhimata means it can be number value, some value, it can be some value. That's right. C is an arbitrary constant. Okay, this is the first rule. So n unequals to -1. So you can't apply this law to integrate this. This means this. So you can't integrate this. You can't integrate this. Okay, you can't integrate this. You can't integrate this with this law. There is another law. I will teach you. Please wait. Okay. Now you can differentiate x squared is x. It cannot be equals to -1. No? As first example, you can integrate x dx. What should be the answer? X 1 plus 1 over 1 plus 1 c. So answer is x squared over 2 plus c. How we integrate x squared? The integration of x squared is x cube over 3 plus c. That is the way how we integrate these things. Okay. Have you any problems here in differentiation part also? I always put in some differentiation videos also for you from next week. I think you should remind the differentiation for the integration. So don't panic. We can go this journey, okay? Okay. If you have any questions, you can hands up and ask from me. Now the session is over from here. The session is over from here. Oh, Hasiru, you ask some questions on sin A cos B. Hasiru, are they are clear for you now? Uh, okay, hands up. Who got this? Okay then. Write these things. Okay, after this, we can go the session. Okay. Okay, now these are the final things. However, we can do those things like this. So tomorrow is the fresh start of integration. The today session is over now. I think you do a work in our session, and if there is any doubts here, you can tell me. Then we can go in our future lessons and we can start the integration tomorrow 7:30 p.m. Okay then good night all. Thank you for the joining with us. Okay, welcome. Okay, if you have any questions or doubts, you can ask from me. uh, then okay. Okay, If you have any questions, you can ask from me. Otherwise, you can go now. Okay. Let's do these questions, please. 1 minute. Okay, okay. Yeah, sure, sure, sure. Have you sent some questions, Sophie? Okay. Thank you. Thank you, Tarusha. Okay. Tomorrow is our fresh start of integration now. And in Friday, there is applied lessons. We starting applied lessons. Think relative motion. Relative motion we starting Friday, and Thursday night we starting integration. Okay. Thank you. And there is yeah, there is 2 questions for you, no? Okay, here. I will do those things. Please wait. Okay. Okay, Sophie. Your physics tutorials are not forget, not forget. I will send you those things because the Friday is physics, no, Sophie. In this week, Friday, physics first part. In next week, Monday, physics second part. So busy nowadays also. Okay. After next Monday, I will free. Then I will send you the I will send you the physics tutorials for you. Okay. Your question is sine inverse 1 minus x 1 plus x. No. Okay. You should differentiate this. Here 1 over 1 minus 1 minus x squared 1 plus x squared and square root. Okay, Sophie? Square root. Then now we differentiate sine inverse thing. And now we should, that's the thing, no? Now we should get into this. Oh, now we should get into this square root 1 minus x and 1 minus x. So it should be need our, so rough paper is needed to here. 1 minus x 1 plus x. I separate two square roots. I separate two square roots and I'm going to differentiate this. How we differentiate this? Getting this, pick 1 plus x square root and differentiate this. The differentiation of this is 1 over 2 1 minus x square root should be multiplied with minus 1 because the sign of x is negative here. And minus, we first pick this, now pick this. Now pick this 1 minus x square root and just differentiate 1 plus x. It is 1 over 2 1 plus x square root. See, it is very easy to keep reminder the differentiation of square roots. And it should be multiplied with just 1 because it is 1. It's 1. And don't forget there is 1 plus x square roots squared also in the denominator. So that is the differentiation of that. So we should apply this in here. How we apply? This is also minus. This is also minus. Then what happens? See, minus 1 plus x. See, minus 1 plus x over 2 1 minus x minus 1 minus x 2 1 plus x. And this is 1 plus x. It is 1 plus x, no? Square root is removed. Now, in here, we can get the common denominator here. It is 1 plus x squared. See, 1 plus x squared minus 1 minus x squared square root. Now this is 1 plus x squared square root. No? So it is 1 plus x. It will jump into the upper layer, 1 plus x. Do you understand? Is it okay? And here, what's happening? Here also we can get a common denominator. When we get a common denominator here, it is minus. When we get a common denominator here, minus. See, 2 is common for both terms. 1 plus x should be 1 plus x and 1 minus x should be get 1 plus x square root and 1 plus x. It is 1 plus x. Minus 1 minus x and 1 minus x is also 1 minus x. In the denominator, it is 2, 1 minus x square root and 1 plus x square root, and don't forget this 1 plus x also. So we can cut off this 1 plus x. Okay. Then, oh, please wait, Sophie. Ink cover. Then we can, this is 1. See, in here, I think 1 plus x squared minus 1 minus x squared, these simplifications should be done in a separate paper, Sophia. It is very easy. Don't go to simplify these things in here. It will be very painful. 1 plus x, but do those things in a rough paper or side. In same paper, these things also should be sent to the examination centers. That's the thing. Minus 1 minus x squared. No? So I can get that 1 plus x minus 1 minus x and 1 plus x plus 1 minus x. Then x and x cut off. It is 2. Here 1 and 1 cut off. It is 2x. So it is 4x here. This is 4x. Then what happened in here? Minus 1 and minus 1 is minus 2. Minus x and plus x. X will be vanished. Minus x and this is plus x. And only there is here 2 square root 1 minus x 1 plus x. So Sophie, this is the answer. 2 also cancelled out. So what's the final answer? Minus 1 over 4x square root 1 minus x squared. This is the final answer, Sophie. Do you understand? Oh, have any problems with you? Okay, Sophie, okay. There is another question also, no? Yeah, we can do that also. Okay, Sophie. Did you write this? Have you sent some half right then half wrong again? Try new methods. What, Sophie? I did 3 pages and cut off them all. Oh, you did 3 pages. Oh, half right. Oh my God. Don't give up. Okay. I told you these things will make perfect. These things will make you Perfect. Okay, don't give up. Did you finish this writing? Did you finish this, the writings of this? Okay. Okay, Sophie. The other question, no? Uh, okay. So, Sophie, what's about your works now? Can you write? We have to start paper class also. Can you write papers in at your home? And can you send me the PDFs to check? Huh? Okay. Not try, yeah? Not try, not try. After this week or after next month, after next week, we have to write some small paper. Okay. Don't try, do it. Huh? Okay. Here it is tan inverse 1 plus x squared square root minus 1 over x. Differentiating. How we differentiate? 1 over 1 plus the square of this entire thing. Oh, see? My God. This and this. Okay, okay, Sophie. How? And we should differentiate this also, no? How we differentiate that? I think it is better to fill some ink. Otherwise, I become lazy. When the pen is with not shine, it is very pain for me. I want to pen becomes more shine. Then I get motivated automatically. Okay. Differentiation of this, no? 1 plus 0. 1 plus x squared. Okay, 1 plus means don't know what's happening. Minus 1 over x. Also, please say it. One plus x squared. So we have to differentiate this also by after jumping into this function. So it is first x squared is in the denominator and just pick this x. Oh, we should differentiate this. It is very easy, yeah? Because the differentiation of constant is 0. 1 over 2, 1 plus x squared is square root, and this should be multiplied with 2x. Because this is, we should jump into this function also. It's minus. It's minus. And now we should pick this 1 plus x squared square root minus 1. And now we should differentiate x is 1. So this is the, so we can cut off x and 2. In here, I think it's better to simplify, no? It is 1 over, so I can get a common denominator here. Can get a common denominator here. So it is 1 over 1 plus x squared, 1 over 1 plus x squared square root minus 1 plus x squared square root minus 1, and this is x squared, and I can 1 minus 1 plus x squared square root. I will get common denominator here. 1 plus x squared square root minus 1. So there is x squared and there is this common denominator. There is a common denominator, no? This 1 minus this, and there is 1 plus x squared square root. So this is x squared. Then, Sophie, we can get these. I think you can see, no? See, 1 minus, see, this and this becomes 1 plus x squared, and this minus become positive 1 plus x squared square root. So this is 1 plus x squared into x squared. So this one and this one become cut off, and this become minus x squared. Minus x squared plus 1 plus x squared square root over 1 plus x squared into x squared. So that is the final thing. And we can keep that in here. X plus 1 plus x squared square root over 1 plus x squared square root multiplied by x squared. We can't cut off this and this because this is a positive. Then we can get a common denominator x squared, then x squared plus this is squared. Oh my god, this is squared. Oh yeah, It is 1 plus x squared minus 2, 1 plus x squared square root and minus 1. I take the entire square of this. And here there is x squared. It comes to this upper layer. And here it is minus x plus 1 plus x squared square root. And here this is x squared into 1 plus x squared square root. Now what's happened? X squared and x squared will be cancelled. Here minus 1 and positive 1 is cancelled. So here it is 1. So this is x squared plus x squared is 2x squared. 2x squared and minus 2, 1 plus x squared square root. And here it is, I will get a minus 1 out. Minus 1 out. X minus 1 plus x squared square root. There is a reason for that. In here it is only 1 plus x squared square root. Now what's happening? In here I pull out 2. Then x squared. Oh, it's x squared, no? Oh my god. X squared minus not 2. 1 plus x squared square root. I pull out 2 here. I want to cut off this, but it will not happening here, no? Any error of this? No, any errors, no? Yeah. I forget this is square. That's why. Okay. Okay. My hope is okay now. It is x squared. Yeah. It's very interesting, huh? I can cut off this. That is my life motivation. 1 plus x squared is square root. Best part of my life. This. Okay, then what's the answer? The final answer is minus 1 is here. Don't forget that. And 2 is there. 1 plus x squared is square root. Okay. Best part of my life. Okay. Did you get this? Did you understand? Any problems? Please tell me. Okay. I always understood. Okay. I always get those small. Yeah. Don't think about those small mistakes of it. Okay. Those mistakes will make you perfect. Okay. You think in one day I will success. Not today. It is okay. Only we should success at the exam, Buddha. Okay. Only we should success at the exam. Okay. No need to success always in our journey. Okay. It's okay if we success in our final destination. That's the thing. No one will ask you about the previous mistakes. So think one day I will success in those simplifications. That's the thing. Okay then. Any questions you have? We can discuss. Otherwise, it is okay. Okay then. Sure. It's my duty. Okay. Okay, then hard work. Your exam is in next year. You are the batch now at the final batch in A levels. Okay. Okay. Good night. Well done. Work hard. Bye.